Hello, so today I wanted to talk about families in the periodic table and then two trends that for first ionization energy and something called electronegativity. Now, first off, there are families in the periodic table that have similar characteristics as you go down the group. Let's start on the left side. On the left side of the periodic table, they're alkali metals, and those are things like lithium and sodium, and they tend to be really, really reactive, and they're soft, and they are metals, and they tend to lose a single electron and become a +1 ion. Next to that, the second column of the periodic table are known as alkaline earth metals, which are things like calcium. And they tend to be a little bit less reactive than alkali metals, and because they have a full s orbital, so they do tend to form +2 ions, but it is a little less prone to lose the electrons because again the s orbital is full. So they are reactive, but not as reactive as alkali metals. In the middle of the table is the transition metals, which are kind of the metals that people think about, like iron and copper and stuff like that. And they have d orbitals, is the electrons that they're filling. On the right, so the left side of the table is metals. The right side of the table is nonmetals. Now, if we start on the extreme right, we have noble gases, and noble gases have full valence or energy shells or valence shells, and because they are full, they don't have a tendency to gain or lose electrons, so they do tend to be completely unreactive. One column in from that is the halogens, things like chlorine and bromine and fluorine, and they are missing a single electron from a full valence shell, and because of that, they do tend to be quite reactive. They tend to form a -1 ion as they gain that one electron. Um, Up in the upper right corner are a number of other nonmetals, things like nitrogen and oxygen and carbon. Um, so they're up in here. And between the metals and the nonmetals are some elements known as metalloids, which things like silicon, which have some properties of metals and some properties of nonmetals, which makes them fairly useful in certain applications, such as like solar panels and things like that. And those are really the things that we want you guys to be aware of and know the characteristics of and where to find them on the periodic table. So once again, alkali metals, alkaline earth metals, the transition metals, the metalloids, nonmetals being actually everything over here, the halogens, and the noble gases. Now the periodic table was kind of the arrangement that's there now was from Mendeleev, and he's kind of the big name in that in terms of he figured out how the periodic table kind of fits together, and he actually used patterns to actually predict characteristics of several elements that had previously not been discovered. So he hypothesized what the characteristics would be and was actually correct. Now, again, just to kind of recap metals and nonmetals, metals are on the left side of the periodic table. They tend to be malleable, which means you can pound them into thin sheets. They're ductile, so you can draw them into wires. Again, they do tend to lose electrons, which means that they will become positive ions. They conduct heat and electricity, and they tend to have a luster or a shine to them. On the right side of the table are nonmetals, which are brittle. They're non-lustrous, so they're kind of dull in appearance. They're poor conductors of heat and electricity. The melting points of nonmetals are generally lower than metals. And several non-metal exists as diatomic molecules. And you can remember them from the term Brinkelhoff. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine tend to form diatomic gases. So Br2, I2, N2, Cl2, H2, O2, and F2. So here once again is a periodic table showing the different families. And the groups, I should say. So here, going down the table, is the alkaline metal group. Here are the alkaline earth metals, Here are the transition metals. Here are the metalloids. These are all nonmetals with noble gases and halogens. Now there's a couple trends that we want to need to know about. First one is first ionization energy. And for first ionization energy, essentially what it is the amount of energy that it takes to take an electron away from an element. And you tend to get a decreasing trend as you go down the table. And if you think about that, when you're near the top of the table, the outermost electrons are right next to the nucleus. Thus, the nucleus has a stronger hold on them. When you get further away from there, there's a lot of other electrons between the nucleus and the outermost electrons. Those tend to get in the way of things and shield and make it easier to pluck off a single electron from the outside. Now, as you go left to right in the periodic table, it tends to increase. So it gets harder and harder to pull away the electron as you get more and more toward the right side of the table towards the noble gases. And maybe one way to think of that is on the extreme left side of the table, there's only a single electron in the outermost shell. So if you lose that one electron, you then have a full valence electron and it's very stable. Same thing with the second row, the alkaline earth metals. If you lose 2 electrons, then you have a full valence shell. It's fairly stable. But as you're getting further and further over, it gets harder and harder to take them off because instead of wanting to lose electrons, there's a tendency for these elements to gain electrons to get to the noble gas configuration by gaining electrons. And since they want to go, well, maybe not want, but since they have a tendency to go that way, losing electrons becomes more and more difficult. The final or second trend that we want you to know about is electronegativity. And that is the tendency of an atom or an element to take an electron from somewhere else. And they're doing this essentially to fill the energy shells and gain stability. And the trend here is very similar to that of the ionization energy, where on the left side of the table, electronegativity tends to be very low. On the right side of the table, it tends to be very high. Generally, we don't really look at the noble gases, so we only go to the halogens. The noble gases don't necessarily have much tendency to they don't need new electrons or more electrons, so they don't tend to have a tendency to get electrons. But the halogens, if they gain a single electron, they become stable, so they have a very, very strong tendency to gain electrons. So again, you tend to see an increase as you go left to right in the periodic table. For the same reason I mentioned for the ionization energy, as you go down the table, the electronegativity gets less. There's more and more shielding as you go down the table. So the draw or the ability of that nucleus to pull a new electron in gets harder and harder as there are more electrons interfering with the process. So it goes down as you go down the table, and it goes up left to right. And final thing that might be worth mentioning is reactivity. Generally, the edges of the periodic table with noble gases excluded, but the halogens and the alkali metals tend to be the most reactive, and the center of the periodic table tends to be less reactive, particularly at the boundary between the metals and the nonmetals tends to be fairly unreactive. Because the metals are basically reacting by losing electrons, and because of electron shielding, as you go down the table, it gets more reactive. So the most reactive metals tend to be the alkali metals towards the bottom of the table. So things like francium are incredibly reactive. Whereas for nonmetals, they are reactive by taking electrons and gaining electrons. Therefore, with the high electronegativity, the most reactive element is fluorine in terms of the nonmetals. And so that's just a quick overview of the groups on the periodic table and also a couple trends.